Hello students, today I am discussing the stator voltage control method for speed control of induction motors. So there are various methods for speed control of induction motors, that is pole changing methods, stator voltage control, supply frequency control, rotor resistance control and slip power recovery. So using the stator voltage control method, the speed torque characteristics obtained are shown here. Now in this method uh, this method is used to control the speed of the induction motor, and which can be varied by varying the supply voltage. The torque developed is proportional to the square of the supply voltage, and the slip at maximum torque is independent of supply voltage. The variation in the supply voltage does not alter the synchronous speed of the motor. So the voltage is varied until the torque required by the load is developed at the desired speed. The torque developed is proportional to the square of the supply voltage, and the current is proportional to the voltage. So this type of method is suitable where the load torque decreases with speed, like in fan type load. And this method gives a speed control only below the normal rated speed. This method is suitable where the intermittent operation of the drive is required, and also for fan and pump drives. As in fan and pump, the load torque varies as the square of the speed. So these types of drives require low torque at lower speed. This condition can be obtained by applying lower voltage without exceeding the motor current. The next method is controlled by AC voltage controllers. So these AC voltage controllers can be used both for three-phase induction motor as well as for single-phase induction motor. The figure is shown for a three-phase induction motor. So the AC voltage controller consists of 6 thyristors which are arranged in anti-parallel, and in delta connection, the third harmonic voltage produced by motor back EMF causes circulating current through the windings, which increases the losses and thermal loading of the motor. Speed control is obtained by varying the conduction period of thyristors. For low power ratings, that is for in single phase motor, it can be done instead of thyristor pair, a tri can also be used. Now these allow both in single and three phase allow a stepless control of voltage from its zero value, and they are also used for soft start of motors. Now next is the variable frequency control from a voltage source. So for variable this is the speed torque characteristics which are shown. The variation in terminal voltage with frequency is shown in this figure, and V is kept constant above the base speed. Below the base speed, V by F ratio is maintained constant, except at low frequency where V by F ratio is increased to keep maximum torque constant. Corresponding speed torque curves are shown for both motoring and the braking operation. Motoring operation, as you know, it lies in the first quadrant, and the braking is in the second quadrant. So these curves suggest that speed control and braking operation are available from nearly zero speed to above synchronous speed. Now variable frequency control scheme is shown here in this block diagram, where VFVS stands for a variable frequency variable voltage source. V star and F star are voltage and frequency commands for the voltage source. Flux control block produces a sinusoidal command V star for VFVS in order to maintain the relationship of the figure which was shown earlier between V star and F star. Reference frequency F star is changed to control speed, and a delay circuit is also introduced between V star and F star, so that even when F star is changed by a large amount, F will change only slowly, so that the motor speed can track changes in F bar, thus restricting the motor operation for each frequency between the synchronous speed and the maximum speed point. This VFVS can be a voltage source inverter or a cycloconverter. So the same description is written here, you can just go through this. Reference is the fundamental of electrical drives by G.K. Dubey. Thank you.